Mosasaurus hoffmannii was one of the largest marine reptiles of the late Cretaceous, hunting in the oceans between about 90 and 66 million years ago. It lived in warm, shallow epicontinental seas that covered large parts of what is now Europe and North America, sharing these waters with fish, sharks, and other marine reptiles. It was a powerful, streamlined predator. Mosasaurus was part of a wider group of marine lizards called mosasaurs, closely related to modern monitor lizards and snakes. They evolved from land-dwelling reptiles that moved into coastal waters and gradually became fully marine hunters. Over millions of years, their limbs turned into paddles and their tails became powerful fins, better suited for life in open water. By the end of the Cretaceous, mosasaurs were among the dominant predators in the world's oceans, with fossils of Mosasaurus found on several continents. In these warm late Cretaceous seas, Mosasaurus hoffmannii sat near the top of the food chain, preying on fish, squid-like cephalopods, and other marine reptiles. Its flexible jaws and backward, curved teeth let it seize and swallow large, struggling prey, much like some modern large marine predators. For many animals sharing these oceans, Mosasaurus would have been the ultimate king of the ancient seas. Seen from the side, Mosasaurus hoffmannii had a long, streamlined body with a deep, barrel-shaped chest and a flexible torso. Its backbone ran from the neck all the way into a downward bent tail that supported a crescent-shaped fin, giving it a profile closer to a shark than a typical lizard. This combination of a rigid front body and a powerful tail let it cruise efficiently through the water and deliver sudden bursts of speed when it needed to strike. Compared to many other marine reptiles of its time, Mosasaurus relied more on speed and maneuverability than on heavy armor or thick shells. Most of the thrust came from that tail, which curved downward at the end and carried a strong, asymmetrical fin. Instead of wriggling its whole body like an eel, Mosasaurus used side sweeps of the tail to drive itself forward, keeping the front half of the body relatively stiff to reduce drag. This tail-driven swimming made it an efficient pursuit predator in open water rather than just a slow, lurking reptile. The skull of Mosasaurus was long and lightweight, with loosely connected bones that allowed the jaws to flex and open wide around large prey. Its main teeth were sharp, conical, and slightly curved backward, ideal for gripping slippery fish, squid-like cephalopods, and other marine animals. On the roof of the mouth, a second row of pterygoid teeth helped hold struggling prey and pull it deeper into the throat, a feeding system similar in some ways to that of modern snakes. All four limbs of Mosasaurus were modified into broad, paddle-like flippers made of shortened bones and extra finger segments. These flippers did not provide most of the power, but they acted as control surfaces, helping the animal steer, stabilize its body, and make quick turns while the tail supplied the thrust. Together, the streamlined body, shark-like tail, and fin-like limbs made Mosasaurus hoffmannii a highly specialized hunter, built for life as an apex predator in open seas. During the late Cretaceous, large parts of the continents were covered by shallow epicontinental seas, warm bodies of water that stretched over what is now Europe and North America. These seas were only a few hundred meters deep in many places, but they formed vast inland waterways filled with fish, sharks, ammonites, and marine reptiles. Mosasaurs like Mosasaurus hoffmannii hunted in these warm, productive oceans rather than along cold, dark abyssal depths. For much of their lives, they would have cruised above gently sloping seafloors and submerged coastal plains, following schools of prey across these ancient seas. Fossils of Mosasaurus and closely related mosasaurs have been found on several continents, including Europe and North America, showing that these predators occupied oceans across much of the globe. In North America, one of the main habitats was the Western Interior Seaway, a broad inland sea that split the continent from the Gulf of Mexico to the Arctic Ocean. In Europe, the type specimen of Mosasaurus hoffmannii was discovered in the Maastricht region of the Netherlands in rocks laid down at the very end of the Cretaceous. Together, these finds show that large mosasaurs were not restricted to a single basin, but were widespread in late Cretaceous seas near the end of the dinosaur age. These inland seas supported rich food webs from plankton and schools of fish to sharks, ammonites, and other marine reptiles. Mosasaurus hoffmannii occupied one of the top positions in this system, sharing the water with other mosasaurs and large predators, but preying on many of the animals below it. For smaller marine animals living in these late Cretaceous oceans, a shadowy shape of a mosasaur passing overhead would have signaled that one of the dominant hunters of their world was nearby. Fossil evidence suggests that mosasaurs often behaved like ambush predators, waiting in relatively shallow water or in mid-water columns for prey to pass within striking distance. Rather than chasing constantly, a Mosasaurus hoffmannii could cruise slowly, conserving energy, and then use sudden bursts of speed when a school of fish or a lone marine reptile came close enough. Its streamlined body and powerful tail made these short accelerations highly effective, especially in warm, well-lit coastal seas. In such conditions, even a short, well-timed rush from below or from the side could be enough to seize an unwary animal before it could react. Stomach contents and bite marks show that large mosasaurs fed on a wide range of animals, including fish, sharks, cephalopods, and shelled ammonites. Their conical teeth were well suited for gripping slippery prey, while some related mosasaurs with more rounded teeth specialized in crushing the hard shells of ammonites and other mollusks. A hunter like Mosasaurus hoffmannii could exploit many parts of the food web, taking whatever medium-sized or large animals were available in these productive seas. Some mosasaur fossils preserve the remains of other marine reptiles, and even smaller mosasaurs inside their stomachs, showing that large forms sometimes preyed on their own relatives. Bite marks on bones and healed injuries on skulls suggest violent encounters between big individuals, whether over territory, mates, or food. In this kind of ecosystem, a large Mosasaurus hoffmannii could treat almost any smaller marine vertebrate as potential prey, reinforcing its role as an apex predator in these seas. For animals living below them in the food web, mosasaurs were not just another threat, but one of the most dangerous hunters in their environment. Mosasaurus hoffmannii became famous not only because it was huge, but because its fossils were among the first major marine reptile remains studied by scientists. The type specimen was found near Maastricht in the Netherlands, where chalk deposits preserved the bones at the very end of the Cretaceous. At the time, these remains were especially important because they helped reveal that the creature was not a land lizard at all, but a fully marine reptile adapted to life in the sea. That made the Maastricht fossils a key part of early paleontological work on ancient marine life. Even today, the discovery is still discussed because it marks one of the classic examples of how a few bones can change what scientists think about an extinct animal. At first, the animal's bones helped scientists realize that this was not a land lizard, but a fully marine reptile adapted for life in the sea. The skull, jaw joints, and flipper-like limbs made its aquatic lifestyle increasingly clear as more complete fossils were studied. As paleontologists compared different bones, they could see that the animal had been built for swimming, not walking, with a body plan very different from terrestrial reptiles. That shift in understanding was an important step in reconstructing Mosasaurus as an active predator of the late Cretaceous oceans. Today, Mosasaurus remains important because it helped define what scientists recognized as a giant marine predator from the late Cretaceous. Its fossils also became part of the broader story of how paleontology grew from early fossil collecting into a modern science. Over time, those remains were studied again and again as new methods, better comparisons, and more complete specimens improved scientific reconstructions. Mosasaurus is still useful today because it shows how a few fossils can reshape our understanding of an extinct animal, its habitat, and its place in ancient ecosystems. Mosasaurus hoffmannii lived until the very end of the Cretaceous, when the great marine ecosystems of its world were about to disappear. By that time, mosasaurs were among the top predators in the oceans, controlling food webs that also included fish, sharks, ammonites, and other marine reptiles. Their success came from a combination of size, speed, and a hunting style that let them dominate warm late Cretaceous seas. When the Cretaceous ended, these dominant marine reptiles vanished, leaving only their fossils to tell the story of their world. Today, those fossils remind us that entire marine ecosystems can disappear, even after a group has ruled the oceans for millions of years. As one of the largest hunters of its time, Mosasaurus occupied the uppermost part of the marine food chain. Its size, speed, and hunting style made it a constant threat to anything smaller that shared its waters. In many ways, mosasaurs like Mosasaurus filled the role that big sharks, killer whales, or other apex marine predators would later occupy in different oceans. That combination of power and efficiency made them one of the most successful marine predators of the late Cretaceous. Even now, their fossils show just how dominant large reptiles could become in ancient seas. Even though Mosasaurus disappeared with the end of the Cretaceous, its fossils still help scientists understand how marine reptiles evolved and dominated ancient seas. It remains one of the clearest examples of a giant marine reptile built for speed, power, and survival in the late Cretaceous oceans. From a few fossil bones to a complete scientific story, Mosasaurus remains one of the most important marine reptiles ever discovered. Thanks for watching.